All right, welcome everybody. I'm glad to see everybody got the email that we switched rooms. And so I want to talk just for a minute about the switch and like what that implies for us. Maybe some of you have taken a course like this before, kind of in a more hybrid style here last semester or something. But I think it's pretty clear from my email what's going on is you're in one of three groups. Every group will get to come into class 2 days a week. And then the third day of the week, I'll be streaming, as I am right now, onto YouTube. And you can just jump onto my YouTube channel and either watch what we do here in class, that's fine with me. If you watched it a little later, that's fine with me too. If you ever want to actually ask a question, you can join the chat on YouTube. So maybe there's a little bit of an advantage to joining on YouTube, just if you wanted to ask a certain question. But I did this exact same thing for Calculus 2 last semester. And what we found worked pretty well is all of my lectures are actually on YouTube. And so what we did last semester, and I liked, is I'll just assign a lecture. And then everybody will watch it on their own time. And then there'll be a homework attached to that lecture. And you can start doing the homework after watching the lecture. And then what we'll use class time for is we'll just talk about problems. So you can come in and you can ask me problems, or you can ask me, I didn't really understand this part of the lecture. Could you go over that a little bit more? Whatever you need. So this time that we have together is kind of for clarification, answering some homework questions, kind of getting everything locked in. And so there's sort of like, obviously there are pluses and minuses to whatever we do. The minus of being like over in the gym is we're over in the gym, but we're all together. But I also kind of feel like maybe I'm just, when I talk, I feel like I'm a little bit loud, and I felt bad. Anyway, and it's just weird in the gym. So I like being in a classroom. It's nice, and it worked really well actually last semester, in my opinion. So any questions? By the way, like the due dates on Foxtail, a couple people told me they were wrong, and that's correct. Usually what I'll do is once I assign an assignment, I'll put in a due date on Foxtail. So right now, if you look down, all the due dates are not right, but they haven't been assigned yet. So I don't like to go in and assign everything before the semester begins, because what ends up happening is inevitably something gets a little bit off track, and then I have to go in and reset every single assignment, and it's a pain. So as I assign things, I'll put in the due dates, and then everything should be fine. So today I will be doing an actual lecture, because I'm not assuming that anybody has watched anything up to this point. But from here on out, I will be telling you, okay, and now also watch this lecture and get this homework ready. And then we'll talk about it. And I'll never make an assignment due before we've had a chance to talk about it together here. Okay, so you'll watch it. In some ways, what's kind of nice about this, and I think it's nice, maybe, I don't know if you think it's nice or not, but you sort of get more time. One of the challenges of teaching like a calculus class is I'll teach a bunch of stuff, and it's kind of the theoretical part of the mathematics. And then I do some examples, right? And I want to get you ready to do your homework. So, and usually in class, you have time for like 2 or 3 examples, and then that's it. So you got your theory, you got your 2 examples, and it's like, go for it. Here's a bunch of problems, some of which we didn't really do anything like that in class. And it can be frustrating to students at times where they're like, hey, you didn't even do anything like this problem in class. And so I didn't really know what I was doing, and I got frustrated, and I threw some things. But so the nice thing about this is when we go to YouTube, I have more time, so to speak, to give you more problems. So, and you can kind of say, hey, I want to watch like 3 example problems. I want to watch 8 example problems. They're there. And so you have access to more material this way. And plus you can come and ask me questions about it. So usually I have to fit into 50 minutes, like answering homework questions, teaching theory, doing examples. Now in 50 minutes, I'm just doing examples, and all the other stuff is kind of on your own time. That works really well. The negative is you can't really ask me questions while I'm giving the lecture, right? And so that's the challenge, but I'm still gonna be around for office hours. The worst case scenario, I guess you could hit pause if you're watching the video during my office hours, literally walk over into my office and say, hey, I'm watching this and you just said this and I don't know what you're talking about. Okay, so I think overall this could be the better way to do this kind of thing, is to watch the lecture offline and then get to come talk about it together. But it feels different, right? It's a different feel. I understand that some people have kind of said, I wish that you were just giving me the lecture live. And it's like, yeah, I hear that. I definitely hear that, but there's pluses and minuses. Like you just get more if I don't, in some sense. So any questions from anybody about kind of how that's going to work, or concerns, anything I can answer for you before I kind of jump in? Yes.
So you gotta like link the video on your Foxtail every week?
Yeah, they're already there actually. So I did that even if I was going to do the lectures. It's always nice to, and here's the other kind of nice thing is, like, say that you are going to be gone for a day. Well, just jump on the YouTube, right? So in general, I would like you to come to class on the days that you can come to class. It's good to kind of get to know you a little bit and have some FaceTime with you. But if there was ever a time where you couldn't make it, it's really not a big deal. Just jump on the YouTube, okay? And on the YouTube channel and watch it there. So yeah, any other questions? Okay, so today, what I want to do is start talking about limits. By the way, something that I usually say a little bit about, and maybe I will really quick at the beginning of this lecture, because obviously the limits lecture is online. I also have some lectures on YouTube, if you want to watch them, about the unit circle. Okay, and one of the things, I think the biggest hurdle for a lot of calculus students is that for whatever reason, high schools don't really teach trigonometry anymore. They typically kind of smash it together with pre-calculus. So probably I'm just guessing, every one of you probably took some sort of college algebra or pre-calculus course. Am I right on that? Yeah. But I'm guessing that almost nobody took trigonometry. Did anybody in here actually take a course called trigonometry? Oh, a couple. Okay, that's great. Well, you're very, very lucky to have gotten to take that, because I feel like it's hard in a pre-calculus class to really get all the trig that it would be nice to have. But really the big event of trigonometry that you really need to have a firm grasp on going into Calculus 1 is the unit circle, okay? And that's where I find that students struggle the most, is they don't know their unit circle. And then I usually say, about this time in the semester, I say, you really need to know it. No, I'm not joking. You really need to know it. You will thank me later if you learn it. So if you're kind of like, well, I kind of sort of know what you're talking about, let me give you like maybe a 5 to 10 minute rundown on the unit circle before we get started. because I think it's worth it. And so unit circle, what's the big deal? Really what we want to do is we want to be able to recognize what are the sine and cosine and tangent value of different angles, right? And there's some angles that are kind of more important to us than others. And for the purposes of our little example today, I'm going to use radians, okay, not degrees. Typically in calculus, we will be using radians. I actually am a big non-fan of degrees. Okay, I think a lot of people use degrees a lot in high school, and so they're used to it. I don't like degrees very much. By the way, does anybody know where degrees come from? Like, why should a circle be broken up into 360 pieces? Does anybody know? Yeah.
Is it because of the Earth?
Yeah. What about the Earth going around the sun?
Or just like longitude?
Well, that's how we've kind of done it. We've used degrees to kind of say longitude, latitude, and it's kind of like, well, why did we ever do that? Why did we do 360? Somebody came up with this, right? That like, I bet a good way to go around a circle would be in 360 separate pieces. Well, what it ends up being is at one time, people thought that's how long a year was. Not 365, which if it was 365 degrees and you were dividing that into fourths and stuff, that would be sort of bad. But 360 was like approximately a year. So they said, you know, every day you go a degree around the sun. That's where it came from. And it's wrong. Okay, so it's kind of like, it's just like totally arbitrary, 360 degrees. It doesn't have a lot of meaning outside of, it's just what we've said for a really long time. That said, we still need to understand it because that's what people say all the time. So, but degrees don't have as much meaning as radians. Does anybody understand really, like, so what's a radian? Yeah.
Isn't it the length of half a circle?
Well, it's just the length across your angle. But yeah, like if you were doing a half a circle, then it would be the length of half a circle. So if you have an angle, let's say that this is 30 degrees, but 30 degrees, does anybody remember what's 30 degrees in radians? Oh, what is it? Pi over 3 is 60 degrees. Pi over 6. So this is 30 degrees or pi over 6. And what radians is I'm assuming now that this is a circle of radius 1, the unit circle. Then pi over 6 is the length of that piece of the circle. Because what's the length of the entire circle? Let's see, let's remember the circumference of a circle is 2 pi r. R is 1, so it's 2 pi. So to get halfway across would be pi. To get a fourth the way across would be pi over 2. To get, I suppose, what is this? This is a sixth of the way across. To the other side is pi over 6. Some people say that pi should have been all the way around the circle, not 2 pi being all the way around the circle. When people made up whatever it is that pi is, they should have thought that pi, or whatever our symbol is, should have been the length of the entire circle. And then everything would make so much more sense, right? Because all the way around would be pi, halfway across would be pi over 2. Half of the pie, so to speak, but instead we do it like it's half of that. So this is pi, and this is a sixth of the half. Does that make sense? So anyway, radians are just the length on the actual circle of the angle. So that's what we mean by a radian. And I think radians, the nice thing about them is they have actual meaning, where degrees are just kind of like something people made up because it seemed good at the time. Okay, so this is radians, and we have some angles that are kind of important to us. The first of them are, this is pi over 2. Up here is pi over 3. And then like halfway between, it's pi over 4. This is angle 0, typically we call that. And then we keep going, right? And what's important here is you should be able to recognize, first of all, just like where do all the angles fall? Like what is the next angle that I'd put on here? That one. Yeah, that's 2 pi over 3. And remember, if you think of it in terms of half of a pi or half of the circle being pi, then everything else kind of falls out because this is half of that. This is a third. This is 2/3. This is 3 pi over 4, right? This is what? 5 pi over 6, and so on. And now you can just kind of figure out the rest if you wanted to. This is 3 pi over 2, and I could keep going and fill the rest in. Maybe I will. What's this one? This is the fourth. I suppose it's 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. Then we can add in the 6. Let's see, this is 7 pi over 6. This is what? 2/3, 3/3, 4 pi over 3, 5 pi over 3. And this is 11 pi over 6. Okay, so those are all the important angles and we can figure them out. But what's nice is I don't really want to have to think about it very hard if I say something like, okay, you've got 5 pi over 4. What you should be able to sort of quickly do is figure out which of the 4 quadrants that angle is in. Okay, that's really helpful. If you know what quadrant it is in, that makes your life a lot easier. And the reason it makes it easier is something that I learned when I took trigonometry, and maybe you did too, is the 4 quadrants can be remembered as a smart trig class. This is what I learned. A smart trig class. So all of sine, cosine, and tangent, this stands for all, sine, cosine, and tangent are all positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant. And only cosine is positive in the fourth quadrant. So if you remember a smart trig class, that helps you to remember, oh, okay, I'm at 7 pi over 6. So that means that tangent's positive, sine is negative, cosine is negative. Does that make sense? So if you remember this little ASTC or A smart trig class, it helps you to remember where are the sines and the cosines positive or negative. Now, at the end of the day, sine and cosine are not something very complicated. And I think this is another thing that kind of gets to people. It's like, well, what is sine? What is cosine? And maybe if you've taken physics or something, you have a little bit better grasp of this. But when I say something like sine of pi over 6, what is that? Anybody tell me? Yeah.
Opposite over hypotenuse.
Okay. Yeah. So that's one way of thinking about it. Is it's the opposite side over the hypotenuse. on a unit circle, if I made like this, here's the point that I'm really concerned with, and I can make a little triangle here. That's a right triangle. And on that right triangle, the opposite side is this side, right? And the hypotenuse is this side, but what's the hypotenuse on the unit circle? 1. So really, we're just talking about this side, whatever that is, over 1. So it's just this side. In other words, it's just the y value of that point. And cosine is just the x value of this point. So all that cosine and sine are is an x and y value. Right? Cosine's the x value. Sine is the y value of a point on the unit circle. So all sines and cosines are just x and y values of points on a unit circle. That's all they are. Okay, so, you know, when you take a trig class, it's like, man, my mind is going crazy. What's going on here? But really, it's like, we're just talking about x and y values. They just all are on the unit circle. And so we call the x values cosines, and we call the y values sines. And so this is actually a really, really helpful thing to think about when you're doing trig stuff, is that cosine values should always kind of make you think of x, or the x-axis. And sine values should always kind of make you think of y values. Okay, so if you keep that kind of loosely in your head, it's not perfect, but usually it's right, that it's like cosines and x's go together, sines and y's go together. And that's a really good thing to kind of just keep in your head. It makes things make more sense. Okay, we haven't actually done any like sines or cosines yet. We've just written down the angles. And so the question is, well, so how do we overlay our sine and cosine values onto this? So let's start with, oh, I don't know. Let's just start with sine of x. Sine, or let's just call it sine of theta. Okay, so how do we figure out the sine values of these things on the unit circle? Now, first of all, what I know is is sine positive?
Sine positive in the first quadrant.
In the first quadrant and in the second quadrant. So it's kind of like in between these two quadrants is like the angle that is pi over 2, right? That is where sine is 1, right? Sine is 1 in between the two quadrants where it's positive, because it's 0 on these two axes. So what I can remember about sine is up at this angle, pi over 2, sine is, I should look at that a little bit, sine theta. The sine of this angle is 1, right? So sine of pi over 2 is 1. And the other way I think about it is like the place where sine is 1 or negative 1 is on the axis that it's associated with. And what did I say sine should make me think of? Y. So sine and y are buddies. And so sine is 1 on the y-axis. Sine and x are like not friends at all. They're like total opposites. And so over here, you would expect that it's 0, and it is. And over here, you'd also expect it to be 0, and it is. Because if you're out at this point, what's the y value? 0. And when you're over here, what's the y value? 0. And all that sine is a y value, right? So when I think of a point, like let's say the angle pi over 6 is somewhere like right here, what should be bigger, sine or cosine? Cosine should be bigger, sine should be smaller. Agreed? And maybe if you remember from your trig, I'll just put in these other angles too. that, does anybody remember what is sine of like pi over 6? I hear square root of 2 over 2. That's a pi over 4. Pi over 4 is square root of 2 over 2. Does anybody remember what's sine of pi over 6?
Square root of 3 over 2, right?
That's this one. This one's square root of 3 over 2. That's pi over 3. This one is half. Okay, but let me show you something, and this is like extremely cool, and I feel like most trig professors don't even teach this, but it just makes me so happy. What if I just put a square root over this one? That's the same thing, right? Square root of 1 is 1. So this is 0 is also equal to square root of 0 over 2. Isn't that true? Although that's a stupid way to write it, it's true. 1 is the square root of 4 over 2. Isn't it? So here's the pattern that you need to remember. 0, 1, 2, 3, 4. Can we do it? Yes, we can. Okay, we can remember that pattern. It's so easy, right? It's just like, it's square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2, and then we have to, y starts going down again, right? It was going, the y values were getting bigger, and then they start to get smaller. So it goes square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, otherwise known as 1/2, or square root, and then square root of 0 over 2, which is also known as 0. Then the y values start to get negative, right? But so this one should be negative 1/2, negative root 2 over 2, negative root 3 over 2, and negative root 4 over 2, which is otherwise known as negative 1. Then it starts to go down again because the y values are getting closer and closer to 0 again. So this one's negative root 3 over 2. This is negative root 2 over 2. And then we've got negative root 1 over 2, or just negative 1/2. And then we're back to 0. So really, if we look around this circle, this is what we need to remember. It's 0, 1, 2, 3, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 3, negative 2, negative 1, 0. And so it's kind of like at different positions, you can kind of think, which is the sine bigger or is the cosine bigger? And that gives you everything you need to know. Or is it on the axis? Because if it's on the axis, it's either 1 or 0. And it's either the friend or it's not the friend. So like if I say sine of pi over 2, I'm like, oh, that's on the y-axis. Sine and y-axis are friends, so it's 1. And if I say, well, what about 2 pi over 3? And I'm like, well, that's pretty close to the y-axis. It's the one that's really close. So it's close to being all the way at 1. So what's the one that's just lower than 4? 3. So it's square root of 3 over 2. So if you know the positions of the angles, you easily can figure out the sine value. Now, the only thing that changes when I change to cosine is I take like the steering wheel and I turn it like this. Everything changes because cosine is 1 over here and negative 1 over here. So all the values just shift. So let's rewrite, except I'll use cosine. The key here is that you don't have to just memorize some table. That's stupid. You need to understand. And if you understand what is going on, you don't have to just sit there and like, I hate this. I have to memorize this. It's like, no, you just understand and then you just know. So that's how you should learn these. Okay, so let's talk about cosine of theta. So now we know cosine is buddies with the x or y axis. It's cosine and x are friends. Okay, so that means this is 1. But once I know that that's 1, I can fill the whole thing out. Right, because this is, if you like, this is the square root of 4 over 2. Right? And so on either side of that is a square root of 3 over 2. And notice that I said that cosine is positive in the 4th quadrant. That's why, is because x values are positive over on this side of the circle. X values are negative over on this side of the circle. Right? Okay, so it makes sense. Here and here then should be square root of 2 over 2. These two should be a half. And these two should be zeros. Then these should be negative 1/2. Negative root 2 over 2. Negative root 2 over 2. Negative, let's see, where are we at? Root 3 over 2. Negative root 3 over 2. And then finally, minus 1. Okay, so if you can remember the location of the angle, everything's free. So if I say something like, what is sine of 11 pi over 6? Then I just have to remember, okay, where's the 11 pi over 6? Oh yeah, it's not the one that's 0, it's the one just below. And I'm doing sine. So sine likes the y-axis. That's more x value focused than it is y value focused. So it's a root 3 over 2, but sine, a smart trig class, is negative. So it should be what? Okay, sine, it's more, 11 pi over 6 is more x. So it should be negative 1/2. And is that right? Yes, it is. Okay, negative 1/2. So I just have to think, where is it? Is sine positive or negative in that quadrant? And then is this more of a x-focused angle or more of a y-focused angle? In this case, it points more x than it does y. So I know it's closer to, in this case, it's more x, so it's lower because x is 0. The x-axis in this case is 0. So hopefully this is helpful. And it should make it so, at the very least, if you are taking an exam or something and you're kind of like, oh geez, I forgot the sine of 2 pi over 3. You could reconstruct the unit circle yourself and then just figure it out. Everybody with me? Any questions? Okay, I think something that is the natural next question is like, well, you didn't do tangent though. It's like, that is true. I did not do tangent. And the reason why is I don't even, honestly, if I'm being, I don't even like know my tangent values. But I know my sine and cosine values. And sine and cosine give me everything else for free. Like now I know my secants, I know my cosecants, I know my cotangents, I know my tangents, because they're all built out of sines and cosines. So if somebody said to me like, what's tangent of 3 pi over 4? Then I would say, oh, well, that's sine of 3 pi over 4 divided by cosine of 3 pi over 4. Right, and then I just have to remember what my sine and my cosine value are. Sine A smart, it's positive. 3 pi over 4 makes it root 2 over 2. And then A smart, that's negative, and that's also root 2 over 2. So it ends up just being negative 1.
Isn't every value of tangent just 1? And then in other words, negative or positive?
For the fourths, it is. So, so if it was at a fourth, like here or here or here or here, yes. But let's take another one. Let's take like a tangent of pi over 6. So that's sine of pi over 6 divided by cosine of pi over 6, correct? Sine of pi over 6, so pi over 6 is this angle. Sine is that, that's kind of a small y value, right? So we know that this should be 1/2. That's a half. And this is cosine of pi over 6, that's a big x value. So that's √3/2. And so that's, if I flip and multiply, that's a half times 2/√3. 2's cancel. I get 1/√3. And if you like your denominators rationalized, then that's square root 3/3. Make sense? So not for, and especially like tangent of 0 is 0. Because sine of 0 is 0. And so the top is 0 and we get 0. Anyway, is that helpful? Hopefully that's helpful in some ways. And I just want to make it so that this isn't one of the things that trips you up as we go through this course, is that you don't really know your sines, cosines, tangents, and so on. And of course, there's some little things that you just need to remember about trigonometry. So the basics, of course, are that tangent of any angle is sine of that angle over cosine of that angle. Cotangent of an angle is cosine of that angle over sine of that angle. Secant of theta is 1/cosine of theta. Cosecant of theta is 1/sine of theta. And then I guess you could also say that cotangent of theta is equal to 1/tangent of theta. All of that is true and helpful. So all of those things we need to know. But notice that once you know your sines and your cosines, you can do anything. So you don't really need to memorize like the secants of angles. You just need to know the cosine of an angle, and then you know its secant as well. Okay. And then somebody also mentioned, right, like the thing that people remember from calculus is like opposite over adjacent, opposite over hypotenuse, all of that stuff. I learned it as a happy old heap of apples. I don't know, but, or some people like have like, is it Sakatoa or something? Yeah, Sakatoa. I never got into that one, but whatever. But at the end of the day, all that stuff is saying that you have a point up here, you're looking at this angle, and this is a right triangle, right? And when we talk about sine is this guy over this guy. So it's really just this thing. It's not this over this, it's this. But if we change the size of the circle, then things change a little bit. But on a unit circle, what we're talking about is it's just the height. That is sine. So if this is theta and this is a unit circle, then that thing is what we call sine of theta, is that distance. This distance, the x distance, that's what we call cosine of theta. And then you could kind of say, well, then what's tangent of theta? Well, tangent of theta is the ratio of sine to cosine. That's one way to think about it. There's another way to think about it as well. This one's a little more weird. If I went out to the tangent line of the circle, it's weird that it's called that, but if I went out to the tangent line and looked at this triangle, this is also a right triangle. And then what I could say as well, what is, now if you say that it's the opposite over the adjacent, this side is the opposite side. This side is the adjacent side. What's the adjacent side's length? 1. So this opposite over this adjacent is what we would call tangent of theta. And it's on the tangent line. So that's why you call it the tangent line, is because the value of tangent is sitting on that line with respect to the angle. Okay, fun stuff, huh? So that's your like crash course in unit circle trigonometry before we get into calculus. But we just use it right off the bat, and you're kind of expected to know your unit circle trig. So I just thought I'd give you a little bit of a crash course. All of this, by the way, I have videos online for. So if you want to watch this again at any time, just watch my YouTube video on it. Any questions? Okay. So I think what I want to do is, there's like 8 minutes left. Let's just end there, and I'll assign the first lesson, which there's a YouTube lesson for in week 1. And then the first homework assignment. On that week, I've put 2 homework assignments, like 2 lessons and 2 homework assignments. I'll move it. So the second one will move to next week. So really just the first lesson, which I believe is 2.2. By the way, let me tell you something. The lesson numbers, it was kind of, I used a different book to make some of these lectures. So it doesn't match up. So when it starts the video and it says, in section 3.8, and it's like 2.1, and you're like, whoa, this is wrong. It's like, it's not wrong. Okay, it's right. So if it's lesson 1, the link is correct, and it's the right lecture. Don't worry so much about what I said the section number was when I started the lecture. Okay, everything should be fine. Any other comments? So yeah, so watch the lecture over the weekend, start the homework and do it to the best of your ability. Bring it to class on Monday, or if you're not here on Monday, bring it to YouTube on Monday, and we'll talk about that homework and the problems, and then we'll assign the next section. Sound good? Yes, sir.
Our homework's due at night.
They're due at 11 at night. I'll always make them due at 11 p.m. The night that they're due. Yeah. Any other questions? Okay, have a great day. I will see you on Monday.